class 9 presenting before you the seminar of sound chapter. Before that, we'll see definition of sound. Sound is a form of energy, as you already know that light and electricity are the forms of energy. Just like that, sound is also a form of energy that helps us to communicate with each other. Now, how is sound produced? It is produced due to the vibration of object. By the way, what is a vibration? Vibration is a to and fro or back and forth motion of an object. For example, to observe vibration, if you hit a tuning fork on any hard object, then it vibrates rapidly back and forth, which is visible to our eyes, and that is the reason why we hear the sound of tuning fork. How is sound produced? As we learned before that, sound is produced by vibrating objects. In fact, when we speak, sound is produced, right? That sound is also due to the vibration which is produced in the vocal cords which are present in throat. Before we discuss further about sound, let us first deviate a bit and let us know what are waves. A wave is some disturbance that travels through a medium. Based on the direction of waves, waves are classified as longitudinal and transverse wave. A longitudinal wave is a wave in which particles of the medium move in a direction parallel to the direction of propagation of waves. Whereas transverse wave, particles of the medium move in a direction perpendicular to the direction of propagation of waves. This is how a longitudinal wave moves. This is how a transverse wave moves. Based on how the wave travels, waves are classified as mechanical wave and non-mechanical wave. A mechanical wave is a wave that requires material medium to travel. For example, sound wave. A non-mechanical wave is a wave that does not require any material medium to travel. For example, light wave. That's why light can travel through vacuum, so that only sunlight travels through outer space and reaches us. Sound cannot travel through vacuum as it is a mechanical wave. So we can say that sound mechanical wave. Sound can travel through medium, that is solids, liquids and gases. Sound travels faster in solids compared to liquids and gases. We are learning about a wave because sound is a wave. Sound is a wave. Now we'll see propagation of sound. We'll take a tuning fork, we'll hit to any object and it is vibrating, which is producing sound. When it moves right, the air which is present beside the tuning fork gets pushed and compressed, that is, the air particles come closer to each other and there is a high pressure region. Now the tuning fork moves towards left. The particles present beside the tuning fork moves far to each other and there is a low pressure. When the tuning fork vibrates, a series of high pressure and low pressure regions are formed, which are called compressions and rarefactions. In this image we can see that this region is high pressure region, as they are close to each other, called compression, and in this region it is low pressure, called rarefaction. The final result is that the disturbance travels in the medium which reaches our ears. Since the motion of the particles is parallel to the direction of wave propagation, we can conclude that sound wave longitudinal wave. In the propagation of sound, the particles of the medium don't travel all the way from the object to our ears. Each particle is just displaced from its position for a while and the disturbance travels in the medium to reach our ears. The scientific study of sound is called acoustic. By this, I conclude my words. Thank you.